Hello, and on behalf of the Global Independent VMUG organization, I'd like to welcome you to today's webcast, pNUMA and VNUMA Save Your Large SQL Instances from Certain DoomA, presented by Shawn Meyers from the House of Brick and Rob Girard from Tintri. I would like to thank you for participating in today's webcast and for your continued participation in the Global VMUG program. Just as a reminder, VMUG offers a number of benefits to our members, including complimentary local VMUG meetings and full-day conferences taking place around the world, VMUG Voice, our monthly e-newsletter, access to the VMUG website at www.vmug.com, educational webcasts like these, and the ability to subscribe to VMUG Advantage, a benefits package only available to VMUG members that provides discounts on training, exams, licenses, eval experience, and VMworld. Make sure to take advantage of everything VMUG has to offer. And before we begin today's presentation, I have 3 quick housekeeping notes. First, we are recording today's session and we will make the recording available for on-demand. You can expect to receive a follow-up email directing you to the recording. Second, we will be holding a Q&A session throughout the presentation. All questions will need to be entered into the Q&A widget window to ensure the speakers receive and see them. They will be addressed one by one accordingly. You can learn more about VMUG by clicking the documents in your resource list widget. Third, there will be a short online evaluation that pops up when you leave the webcast. Please make sure to take a minute to let us know what you thought of today's session and what you might like to see going forward. And with that, I'd like to welcome our speakers, Rob Girard and Shawn Meyers. Both Rob and Shawn are deeply technical and presented on today's webcast last week at VMworld. For all of you who missed it, now is your chance to catch that highly rated session. And for those who did attend, they will be presenting the visuals that were absent due to their format at their VMworld session. Now I would like to pass control over to Rob and Shawn so we can get started. Thank you.
Thanks, Chelsea. This is Rob Girard here, and Shawn and I had a lot of fun putting this together for you, so we really hope you enjoy it. So I'll let Shawn introduce himself here.
Sure. I'm Shawn Meyers. I'm with House of Brick Technologies. I have a lot of experience in VMware and SQL Server and been doing virtualization for quite a few years, and then SQL Server for 20 plus years now, or right about 20 years now. Let Rob go ahead and introduce himself.
Thanks, Shawn. So I used to be a Tintri customer, love the technology. Now I work for Tintri as a technical marketing engineer. I'm in Mountain View at headquarters, and I've been there for just over 18 months now. I've got over 18 years experience in IT. Prior to becoming a vendor, I was on the, I guess you could say, the customer side. So, in the data center trenches for most of my career. So for all of the audience, I can completely relate with you. I have over 10 years experience with VMware specifically. As a generalist, VMware just seemed like the sweet spot on where my career ended up. I'm a vExpert. I've got a bunch of VCAPs and some VCPs, MCSE, CCNA, and TCSE, which is actually a Tintri certified SE. So I kind of like the alphabet soup. So today we're going to, just quick intro, Shawn and I, we met at a SQL Elite workshop that VMware hosted in partnership with Tintri back in April. So VMware handpicked 15 of the top SQL people across North America, and in that group was Shawn. So during that, I noticed that Shawn seemed to, all of them knew SQL very, very well, and Shawn seemed to have a very strong virtual first mentality, like myself, and I thought, hey, this guy'd be great to partner up with and see if we can present a VMworld presentation together. So I reached out to him. He's like, yeah, let's do it. So we put in a few topics. We got a topic chosen on pNUMA and VNUMA. And so we spent about 2 months meeting up once a week. So anywhere from an hour to 2.5 hours a week, prepping for this. And then after every week, we'd meet in between, did a whole bunch of lab work to get all these answers to pNUMA, VNUMA questions that we couldn't seem to find online or that seemed to be gray areas. So we're hoping that today we can bring you the de facto, this is pNUMA, VNUMA, and how it relates to SQL. So we'll just cover, explain what it is. We'll explain balancing and the boundaries. And we'll go through some advanced settings, how to monitor it, go through some of our lab results and findings. and hopefully this is a very educational session that you'll want to refer back to and refer colleagues to if they ever have questions on the topic of NUMA. And I'll hand it over to Shawn here, and you can jump in with some classic SMP.
All right, so not everybody knows what NUMA is, so just to make sure, I'm going to cover what NUMA is and SMP. So SMP, all computers start off as SMP, which is symmetrical multiprocessing. Basically, there was one bank of memory, and the processors all shared the same bus to it. As machines grew larger and larger, the addressing schemes between all this became more and more complex and made it more and more difficult. So the hardware vendors came up with NUMA, which basically stands for Non-Uniform Memory Access. It breaks up your CPUs and attaches memory in banks or in groups. So I might have 2, 4, 8, whatever number of different groups, depends upon what type of CPUs I have and how many CPUs I have and how many cores there are, and determines how the memory is attached. This is how, as you see in the diagram, there's a difference in the top diagram for SMP memory, shows all the memory shared by all the CPUs, versus here on the second diagram below, there's a green interconnect. There's NUMA node 0 and NUMA node 1, and there's an interconnect between the two. If your memory is on one but your CPU is on a different processor, it actually jumps over the interconnect to get the information. AMD NUMA. So AMD and Intel approach NUMA a little bit differently. So on AMD, basically, each CPU has 2 different NUMA nodes. So a 4-socket server can have as many as 8 NUMA nodes inside of it, which confuses some people. The I/O controller is at the bottom, which controls how things are. So what happens, of course, you can have a multiple hops with AMDs between the different NUMA nodes. As you can see, if I'm going from the top left corner to the bottom right corner, I actually have to go through 2 different processes to get there. Intel has has multiple I/O controllers on their systems, and it has 1 NUMA node per processor. The lines in between that form the X are called your QPIs. So if you read the Intel specs, you actually go read the QPI information, talks about how many different interconnects are between there. And you see that each individual CPU has 1 hop to any bank of memory. So pNUMA versus VNUMA. pNUMA stands for basically physical NUMA. So every hardware has a physical NUMA structure. At least all modern hardware typically has a physical NUMA structure, except for desktops. VNUMA is the name we apply to virtual machines, and how the ESXi or hypervisor presents the NUMA information to a virtual machine. Since VNUMA is software, we can tune it when it doesn't correctly match the desired configuration, and there's lots of different settings for it. And Windows and Linux and SQL Server have all supported NUMA for generations. I think Windows 2000 with SQL 2000, actually I think NT4 actually supported NUMA, and then Windows 2000 with SQL 2000 were NUMA aware. Soft NUMA. I bring up NUMA here for one reason and one reason only. People ask me about it, even though it doesn't really matter. Soft NUMA basically is a feature inside of SQL Server that allows you to make a SQL Server SMP machine act like a NUMA machine. This is great for testing, especially if you're a developer and you need to go validate your execution plan and how it parallelizes. Inside of a server that's SMP that has NUMA in already, you should not have soft NUMA turned on. And if you do, turn it off. The VNUMA comes only into play when there are 9 vCPUs or more. Every document you read, it says greater than 8. Greater than 8 actually means 9 or above. I don't know why it says greater than 8. So a lot of people tell me VNUMA takes effect at 8 vCPUs. It does not. It has to be 9 or more by default. If you have 4 or 6 core processors, and virtual machines larger than this, you will have NUMA issues, and you can go in and tune when VNUMA takes effect, which we'll walk through those settings in a few minutes. Actually, the first one here is a NUMA min vCPU, which allows you to change the setting. VNUMA was introduced in vSphere 5 and has been greatly improved, and VMware keeps improving with each generation. And Rob, you want to talk over our testing methodology?
Sure. So, I mean, what we wanted to do is we wanted to get, we wanted to validate results. We wanted to make sure that it was working as we expect. So, we'll cover a little bit of our in-guest analysis, the tools we use there. So, Windows tools was what we were testing with. We'll look at the host perspective using ESXtop, specifically the memory view with NUMA field showing. Then we went into the VMX file. So when we make changes in the UI, what does that actually do to the file? And what about how do power cycles affect it, reboots? Because sometimes you make these changes and should it kick in right away, or do you need to do a reboot in your guest, or do you need a full power cycle? We wanted some answers to that, so that was all done through mostly just text analysis of VMX. Worst case analysis, okay, we wanted to figure out what is going to be the penalty in the event that we have this wrong in the worst way. So for this, we were pinning using CPU affinity and memory affinity to pin processes for a specific VM to specific cores, and the same thing with memory back and forth. And in our lab, what we have had one AMD server to work with, which was a dual socket 16 core with 256 gigs of RAM. The great thing about this is that it gives us 4 NUMA nodes. It did not have a 4-socket machine to test with, so when I wanted to get analysis on how 4-socket would look and feel, this AMD box was fantastic for figuring that out. And I'll cover some of that a little further so you can see how some of the auto sizing works. We had an Intel server, which was a B200 M4 Cisco UCS blade with 2 16-core processors, which is 32 physical cores or 64 logical with hyperthreading, which we are going to cover a bit later as well. I had a Tintri VM store underneath this. We were bouncing between a T850 and a T5080, which is a new all-flash array. We've got our SQL VMs were all Windows 2012 R2 with SQL 2014. And the size and for CPU and RAM varied with our different tests. For HammerDB, which was our app of choice to test for performance and whatnot, we were using a master-slave combo, so I had 10 VMs at 8 vCPUs each. Those would be on other hardware and sometimes on the same hardware, depending on what we wanted to test. Sometimes we were testing all isolated, just the SQL on the hardware, and sometimes we wanted to see how it would interact when there was contention on specific nodes and whatnot. And so when we ran our tests, for a lot of the screenshots you'll see, it was 16 virtual users on each of those against a SQL box that had 24 vCPUs with 224 gigs of RAM. And let's just jump here. So I mentioned some of those in-guest tools. So for Windows, I wasn't even quite sure how to find this on the outset, and it was actually much closer than I thought. So if you just go into Taskman that you're used to jumping into, and you right-click on your graph, you can see the NUMA nodes, but that won't actually break it down into all the different CPUs and which nodes they belong to. However, this is great for determining what you want to represent from in your VM to make sure that your guest actually sees it, because your guest in SQL is going to optimize for certain NUMA boundaries, and you want to make sure those boundaries actually land on the same place as where the physical boundaries are. So go to Task Manager, and if you need more information, click into Resource Monitor from within Task Manager, switch over to the CPU tab. There's a view in the top right of this image shown, and this view you can change to small if you want to see a lot more. And if you look closely at that, if you're able to zoom in, you'll see that we can see our total CPU, and then we can see an aggregate for 4 NUMA nodes in this. And then we can see each CPU and the node they belong to. So the first 6, 0 through 5, belong to node 0, and then the next 6 belong to NUMA node 1, etc. And Shawn, you want to cover the SQL side of stuff?
Sure. Since I'm a DBA, I don't trust my OS. I always go into SQL Server to go look at things that I can. So the first one here is the DMV, so it says DM OS Schedulers. This tells me basically what each CPU core that's presented to my SQL Server and what it currently is doing. I tend to look at this for deep dive troubleshooting, as you can see the different amount of columns and data points on here. we've color-coded it here for ease just to show you the different NUMA nodes as the parent node ID 0s, 1s, and 2s. This is, again, I use for the troubleshooting from when I have some sort of NUMA issue I want to go figure out. The common one I actually start off with is the next slide, the system OS memory nodes, which tells me how many NUMA nodes I have. I have 0 through 3 here, which is 4 NUMA nodes. Node 64 is for the thing called the DAC, which is the Dedicated Admin Console, which is a backdoor you can get in a SQL Server with if your CPU and memory is completely used up on the machine. They leave a little bit available, which is NUMA node 64, to get into as well. So you always see at least 64 and 0 and 64 if you only had one NUMA node, and then it varies by number you have. Now let's go look in how we troubleshoot or how we go look at NUMA on ESX itself using ESX Top. Rob?
Sure. So if you jump into your console on your vSphere box, so just to call this out, our testing in this case was all on vSphere 6. So there might be some quirky things that only show up in earlier versions. Everything that we're presenting is for vSphere 6 unless we've called it out specifically for an older version. So in this case, you go to ESX Top, and then you click M to show the memory view, and then you push F, which will bring up a fields dialog, and in the list it's G that will be for NUMA. And once you turn that on, this is what you're going to see. And the columns that you're concerned with, I've highlighted. The first one's your home NUMA node. And so all the NUMA ones start with an N first. So your home NUMA node, and in this case, the SQL Server is split across 2 nodes, 0 and 1. This is an Intel box, 2 sockets on it. All we have are a total of 2 nodes. And the memory per node is your physical memory of the whole box. Just cut that in half. You've got it evenly distributed on each bank. What we can see here is that our percent local, there's a column there, is 100. So we're 100% local. But this can be a little bit misleading because this is the amount of memory that has actually been written to each of those nodes and the CPUs that are going to be accessing them. When you have 0, 1, in the case of an Intel box where you only have, it's a 2-socket box, you're always going to see 100% local, but it doesn't mean that your accesses are actually being called locally. So this is where it got a little trickier to determine which was which. But for any of the other VMs listed there where they live on one home node or another, we can see that either they've got 100% local accesses or the other. So if it changes to another home node, that will drop to 0% local, and as it starts to use that memory, it will start to localize the memory again and start to bring it into its home node. And then in the background, we just have, in this case, it's 1.8 transactions per minute showing on our HammerDB results. And this is, again, same thing I just covered. I probably should add it zoomed in. So this is a little closer to the fields that we're covering and then what I was talking about there. So the NRMEM is how much is remote memory, and NLMEM is how much is local memory. Those numbers, add them together, will give you your total memory. And ESX has gone and shown you how much percent local it is. So you don't have to do the math there. And I'll hand it back to Shawn, and you can cover the balancing.
Sure. So NUMA balancing is very, very important, making sure your machines are balanced properly. NUMA imbalance occurs when there's a mismatch between the number of CPU memory, or the size of CPUs and memory you have of a virtual machine and the physical hardware. At the end of the day, NUMA is a collection of your memory and CPU resources. So if you have 2 NUMA nodes, your memory is going to be split in half. Example, you have a host with 2 sockets, 12 cores, and 384 gig of memory. Each NUMA node is 12 cores in 192 gig of memory. So if you have a VM with 12 cores and 256, where it's basically bigger than half, you're going to end up with 2 NUMA nodes, and your memory is going to be cut in half between the 2 NUMA nodes. So you'll have half your NUMA nodes, but 6 cores on one NUMA, node 0, and you'll have 6 cores with 96 gig memory on the other one. This is how you want it. If you happen to have an imbalance, is when you force, for example, if you this to run on one NUMA node with 12 cores, and you'd have some memory on node 0 and the spillover, the other 64 gig of memory on node 1, which will cause you to have a problem. VMware rarely makes an imbalance when it uses the autoconfig. Most of the time when I find an imbalance issue on somebody's system is because they have basically tuned and tweak the NUMA settings themselves. NUMApility. So what NUMApility is when I schedule my thread to be on one NUMA node, but my memory happens to be on a different NUMA node. And that can happen for numerous different reasons. And ESXi and, of course, Windows and SQL Server are all NUMA aware, so they actually make decisions on when to do a remote memory lookup versus when not to. And they can determine based upon what they're seeing from a CPU pressure. But when you're forced to do a remote memory lookup, the fact you have to do an extra hop through a CPU can cause as much a performance penalty, which we have seen, and we'll go through the test numbers. Later on and show you what we've seen. But that memory lookup has a cost, which is known as the NUMApility.
So Shawn, there's a question coming in from Stephen, and he's just wondering about setting the SQL max memory when NUMA is in play. What can you tell us about that?
Sure. So SQL max memory should be set on every SQL server just so you don't create memory pressure problems for the OS and or the host itself. When there is no real correlation between SQL max memory and NUMA. So if I had a single NUMA node and they had set max memory set, it works fine. If I have two of them, unless I wanted to, if on the example where we had, let me go back 2 slides, where we had the 256 gigabytes of memory, if I set my max memory to 192 and would fit inside of one NUMA node, I can still be 12 cores on one NUMA node and everything be that way. But of course, wasting the rest of the memory. So if I was using max memory to limit it to keep a NUMA node balance, it makes sense. Other than that, max memory in SQL Server has no real impact on NUMA layout and configuration. All right, so our test we're showing here is we're using HammerDB, and if you go look at the slide, it's kind of small, where we show %local. We had %local of 1% because we kind of tricked and forced the system to work this way. You'll see the dotted line is the consistent running rate when it's configured properly. When we forced it to be not consistent, we had a 40% drop in performance. Penalty will vary by workload. One of the VMware's best practices guides walks through 6 different baselines they used. And some baselines basically had a 1% penalty for it based upon the workload, and others had as great as 80%. We typically see on a SQL Server workload that's on a busy box between 30 and 40% penalty when you have a NUMA imbalance. So VM sizing. So the biggest thing is right-sizing your workloads. Don't oversize them, which you've heard multiple times, but also trying to balance the size of a virtual machine, even the non-NUMA or VNUMA machines, into a balance that your CPUs are designed for. So if you can, and you had a 12-core machine, you want to keep your machines in a 1, 2, 3, 4, 6, or 12-core multiples. So basically you want to have it evenly divisible by the core count. And of course, if you're going above this for your NUMA sizes, you want to keep them in the same multiples, 12, 24, and 36, and up to 48. It depends on how many you have. That will allow the CPU scheduler to give the most flexibility in how it schedules the work, and allows to basically push the most amount of things through each CPU cycle. So an 8 vCPU machine in this configuration on a 12-core box will still run, but you'll lose some consolidation rates. Of course, when SQL servers are being virtualized, we usually don't care as much about consolidation as you typically do for most virtualization workloads. And of course, you always have to remember to leave room for the hypervisor. So if you're going to have a 24-core machine, physical host, and I go create a 24-core virtual machine, I need to leave room for the hypervisor or we'll have problems. Hyperthreading does help with those issues, and we'll get to that in a couple slides. Cores versus socket. So VMware recommends 1 core per socket. This also allows the scheduler to have the most flexibility. If you change from 1 core per socket, you're going to lock in the NUMA configuration, and VMware or vSphere basically can't auto-size as it needs to. So you're forcing, this is how it's going to work. And if you're wrong, you're going to create the imbalance yourself manually. If you assumed you had a 8-core machine and you actually have a 12-core machine, well, guess what? You've now locked in, how many NUMA nodes you're going to have because you chose a different settings with like 2 by 8 instead of, or so you had 1 by 6 or 2 by 8, different numbers. So also one thing that we learned in here that's kind of surprising to us during this process, VMware will determine the NUMA topology on first boot and set it in the VMX file. And it will stay that way. It will not update itself.
Wait. Are you saying that, what if I cold migrate it over to, from Intel to AMD?
If you do a cold migration from Intel
is it going to recalculate?
AMD, it will not recalculate by default. We will talk
about
how to have... Oh, go ahead.
So if I did some cool cross-cloud vMotion that we saw at VMworld last week, same thing, it's not going to recalculate?
Correct. It is not going to recalculate.
And so in that cloud scenario, we don't even know what the hardware looks like underneath.
Correct, which is why you definitely want to stay with 1 core per socket. So when we show you how to force it to recalculate, it will come back and recalculate for you on next power cycle.
And of course, we're going to show everybody how to do that, where the setting is, and make a recommendation to do that all the time so that you don't have to care as much about what your physical architecture is under the hood of where that VM happens to be running.
Correct. So let's finish this slide up real quick. So you use multiple cores basically to save on licensing. So some places where you still need to pay by socket for a license, you want to go and configure your virtual machine to have the right amount, the most amount of sockets to fuse number of cores, just to go and save you the licensing costs. If you're sure of your underlying hardware, you can go ahead and try to match the boundaries. But again, if you're in a place nowadays, you may or may not know, especially if you're in a hosted solution, you may not know your underlying boundaries. When you set multiple cores or multiple sockets, you're going to disable how VNUMA or how VMware can auto-size as needed. And there are places where you want a non-stereo NUMA configuration, and you can change them, by making the settings. And results do vary, so that basically means test, and test. And the best practice guide here, I forget which page it's on, but the vSphere 6 link to this best practice guide, I want to say it's page 44, walks through how this works and why they specify 1 core per socket in a lot more detail.
Okay, and we had a couple questions come up that we can grab right now. So the one question was from Joshua. He was asking about the example of the 12-core servers and keeping the vCPUs divisible by that number. Is that including hyper-threading or not on the physical CPU? So to answer that, we are going to cover an option for whether or not we want to treat CPUs as hyper-threaded or not. So I would say that no, ignore the hyper-threading, but we will cover that particular setting called Prefer HT in a later slide. And here's another one that, Shawn, maybe you can answer this. This is from Joe, and he's asking when it's appropriate to leverage the lock pages in memory option in the Windows OS.
Okay, so lock pages in memory is a operating system setting that does allow some benefits for large pages inside of SQL Server. So you need to turn the operating setting on to turn on large pages. Results may vary on that for your large pages, and you need to test. Bob Dorr has a great write-up on large pages in SQL Server, so make sure you go up. Bob Dorr knows Bob Ward. Bob Ward has a great write-up on it, so make sure you go Google his. Actually, it's a blog post before you decide to go turn that one on. But from a NUMA perspective, there is no differentiation on when or when you should not turn on locked pages. As a SQL Server DBA who does virtualizing large database workloads, I always recommend on any SQL Server that I have locked pages in memory on, I have a full memory reservation in the virtual machine. But I don't necessarily need to have locked pages. It depends on my workload and if I want to use large pages.
And there's one more question here from Manu, and I think I can answer this one because it is a trick question. And it says, if my physical server has 2 sockets times 16 cores, how should I configure an 8 vCPU VM? And so 8 vCPU is is less than 9. So if it's not 9 or higher, there's no NUMA involved at all. So there is no NUMA awareness for that 8 vCPU VM. However, in the event that you're giving that that VM more memory than is available in a single NUMA node, so let's just a simpler example here. You've got 16 cores on a socket, and you've got, say, 128 gigs of RAM, and you've given that VM 224 gigs of RAM. You're going to want to have that evenly split across 2. So this is a case where you may want to impose a virtual NUMA node onto your VM so that it intentionally splits across to the 2 nodes so that it can take the even amounts of memory from the 2 so that you don't have that reverse memory lookup, that remote memory lookup for that all the memory that is not local to the home node.
And so Steven's question basically, go ahead.
No, keep going, Shawn.
I was because Steven's question came in basically looking at a SQL Server and his vCenter. We have 2 sockets and 2 cores each. What is the NUMA impact of this? It's kind of the same answer. It's less than 8 cores, so it does not actually have a NUMA impact. It's going to run it on 1 NUMA node. All right, so back to the slide.
Hopefully we answered Ross's question too. I think that this we just covered that as well, where we are not seeing 100% local. Your memory is split amongst them. Sometimes your memory is not local because of contention with other VMs, and sometimes it's because you've assigned more VM than fits in a specific NUMA node. And so I guess the short answer here is do some experimentation, and hopefully we've given you, by the end of this presentation, you'll have all the tools that you need to know what to look for while you're doing that experimentation to find what fits your environment best. When in doubt, just leave it alone. What we meant to preface at the very start is that these settings that we're talking about are for the largest of the large SQL instances that are virtualized. This is like 1 to 5% of the workloads out there that have large amounts, very large amounts of CPU and memory. For any of your SQL VMs that are 8 and below, and below amount of memory that fits in the NUMA node, I would caution you away from setting any of these things. This is just for the beastie VMs out there.
Okay, so on here basically is you edit settings. You're using the thick client still because we're not with VMware. We don't have to use the thin client. Basically showing here number of virtual sockets and virtual cores per socket. Just let you know what we're talking about. The next slide, advanced VM settings. So all the settings here on the left are different settings you can go change in the advanced settings for each individual VM. They're also listed. They all can be listed in the VMX file. Meaning, though, when you go look at the VMX file, most of these will not be there by default. Once you finally cross the NUMA threshold, i.e. having 9 vCPUs, things will show up automatically. So the first 2 you'll see is the ones highlighted there, the NUMA auto-size cookie and then NUMA auto-size vCPU max per virtual node, which is basically how large your virtual machine, your NUMA nodes are configured by VMware defaults when you cross that threshold. So the ones that say auto-size are the ones that VMware is creating for you. So another one, the NUMA auto-size equal true and the NUMA auto-size once equals false. If you set both of those and you have to go in and add rows and type those in that way, or is how you force the machine to reboot, to recalculate NUMA on next boot. The NUMA.vCPU.min is the one for setting how large you want to have for your NUMA nodes. So in other words, if you had a 6-core machine and you want VNUMA to take effect at 7, you go in and add the line NUMA.vCPU.min equals 7 here, and then now all your 8-core or 8 vCPU machines will now have NUMA exposed to them.
And so this one here, this is a little tip. The setting that we were just showing on the last slide, you can't get to that if your VM's running. So you go into your Edit VM Settings, you go to Advanced, and then the General, where you would normally get that pop-up box with that, is not available to you. And so this was a little frustrating to me to have to power down a VM to try and see the adjustments and the changes. And it was also frustrating because I'm trying to figure out, you know, the state of things during power cycle after it was shut down and this kind of thing. So what I was finding is that I could just use the Datastore Browser. I could cruise over to the folder where the VM lives and just download a copy of that VMX file. And in the screenshot is the tool that I was using, WinMerge, amazing tool if you're not used to it for comparing text files and whatnot. And so as I made tiny little tweaks along the way to just change cores per socket or to pin certain things or figure out if it mattered if a reboot was necessary or not, I would just compare the two. And in this case, you know, I'm comparing a before power and an after power after I had set the CPU to a certain size. So I had set the CPU to 10 CPUs and hit OK. And then it's, you know, vCenter shows reconfiguring VM. And then I grabbed that VMX. And then I powered it on. And then I powered, and then I looked at it afterwards, grabbed it, and sure enough, the two lines that were automatically added over vCenter was that max per node was 5, so this is evenly putting 5 and 5, and was the auto size cookie, I think we cover later, just saying that we're talking 10 CPUs and 1 core each. It's not a string of binary, which I originally thought, which it became a lot more apparent once we had some bigger numbers that made sense. So those two that I was just speaking to, the auto size cookie in this case was we assigned 24 vCPUs at 1 core each. And the auto size node per max, or max per virtual node, shows up as probably as 12, but again, it depends. If we have 16 physical cores, you know, whether we have hyper-threading enabled or not, it can make a difference. So 12 will fit, 24, the main number that we assigned, does it fit inside of your node? And if it does fit inside, then you will just have max per node would just be the 24. But when we say, oh no, 24 is bigger than 16 because we've got to prefer hyper-threading configured to be false. And we say, okay, so we'll just take half and put it here and half in the other one, 12 and 12. But if we had prefer HT equals true, then it would count that as 32 instead of 16, and the 24 would fit inside, and then we'd end up with 24. And for different architectures, we might get different numbers. So one of the things I did on the AMD box was just to look at a box that had 4 NUMA nodes on it to mimic any 4-socket box. And so in this case, what I did was I added, so the first line in here is 9 sockets, times everything is just 1 core. And I wanted to see the auto sizing. So we saw max per node was 5. And so I've broken that down for you to show you 0, 1, 2, 3 are the NUMA nodes themselves and how many cores are in each. So when we see max per node, that's max per node is 5. Any one of those, the max you can have is 5, and the others may end up being the remainder. So 4 and 5. And again, we started at 9 because that's where NUMA kicks in. 10, we have 5 and 5. And as you go down, you see some interesting stuff. When you add 16 cores, you know, across 4 nodes, would you expect to see 4, 4, 4, 4 evenly distributed, or would you expect to see something else? And so here's sort of the cheat sheet of everything that I found. And when I found that max per node to be a strange number I didn't expect, such as going from 22, 23, 24 sockets, and I kick over 25th, and it actually drops down to only 7 per. Anyway, this one hopefully you can refer to later and makes a lot of sense of when you're reading those auto settings out of your VMX, what it's actually doing under the covers. And hot ad gotchas. I'll let you want to cover this one, Shawn?
Sure. Or should we answer questions real quick?
Let's take some questions.
Sure. So the first one I got in here is from Ross. Basically, you don't see these all those NUMA.whatever settings inside your VMX file. Basically means you're using the defaults. Use the VMware configuration guides, and it'll tell you what the default means. You just go to the vSphere Documentation Center, and it'll list them all out. Just Google each one of those. But basically, and in short version,
yeah, and in short, when you look at ESX top, and you look at the NUMA display, you're just going to see a single home node for that VM. There's not going to be multiple nodes assigned to it if there's nothing in there to show some kind of NUMA topology. So I think earlier you had mentioned you had it with 21% local. That's just using all defaults, only one home node.
And then Sean Crawford had a question regarding, so is NUMA always working as observed in ESX top, or is it only working with the OS as aware? Every OS, well, every normal OS, in case we're talking about SQL Server, Windows has been NUMA aware since 2000. It's always aware. So NUMA is always working whenever observed in ESX top as well.
Yeah, and just another note on that, I think with the slide that talks to it, but careful, because just because it says in vSphere that you have 100% local, it doesn't mean that you don't have remote access lookups. The number in vSphere is just showing you memory written and whether or not you have cores on that home node. It is not taking into account the actual memory accesses. To see the memory accesses, you need some inside guest tool. So you can determine if your boundaries are aligned and that you're seeing a NUMA topology in your OS that matches physical. And then in the OS side of things down in the guest, that's where you have to determine where your calls are coming from. And that's some of those guest settings that we saw earlier, and some of those SQL queries can help you narrow that down.
Let's get back to the slides just to make sure we get to the deck before we take more questions.
That sounds good.
So hot add gotchas. So when you turn hot add CPU on, it will disable VNUMA. So you'll always have, if you had a machine that's got more than 9, has more than 8 or 9 or more vCPUs in it, you will have a hot add problem. If you turn on hot add, you will have a NUMA imbalance issue most likely. Hot add memory works fine, except there's one small caveat. In hardware version 8 through 10, it will only add your memory to the first NUMA node, or NUMA node 0. So if you had a 96 gig machine and then you have 2 NUMA nodes on it, and you basically did 48 per, and you decide to go add 16 gig, you'd end up with one NUMA node with 64 gig of memory and one NUMA node with 48 gig of memory. And it'd be that way until you reboot the machine next, which is interesting because I told you earlier that it doesn't rebalance, it doesn't fix underlying NUMA issues on reboot. On the hot add memory, it does, due to the fact of the memory balance is pulled from the CPU configuration. In hardware version 11, it automatically, when you add memory, it would actually add that 16 gig of memory added, would be added 8 gig to each NUMA node, or if you had multiple NUMA nodes, it'll divide up equally. So that's also, it says vSphere 6, but also hardware version 11. So if you had vSphere 6, but you still didn't upgrade your hardware versions, that you still run on 9, you will not work properly. The NUMA configuration here is actually part of your hardware. So update NUMA configuration. So here's the fun stuff, and read the KB link there and down there, basically for NUMA on that page. There's a whole section on it. This is a summary of what the documentation says. So for NUMA, again, calculated only on first power on. Only updates basically when you change the number of sockets or cores. So if I had, if I needed to do a recalculation, I wanted to force it, I just go and edit settings, change the number, reboot, change it back and reboot, and they'll be fixed. Well, that's kind of a pain. When your vMotion occurs between different hardware, the underlying is not updated. So there's 3 scenarios when this happens. So say if I go from, so the first scenario where the NUMA node size configuration is smaller or the same as the new host, there's no real change. Meaning, so if I'm on a 12 core machine and I have a 16-core VM, I'm on a 12-core machine. So I actually have, I'm 8 and 8 across this machine. I do a vMotion to a 16-core machine, it will sit and stay 2 NUMA nodes, even though it can fit in 1. Because the machine, the NUMA, my node size is the smaller or the same. So if the node size is larger but is evenly divisible, meaning if I want, this one was, I had to read through multiple times so I finally understood it. So if the node size is larger but evenly divisible, then the NUMA node is divided up to match. However, the OS does not know about memory locality. Meaning, if I had a 16-core machine and I vMotioned it again, but this time I moved into a 12-core box and I was on one NUMA node before, it will actually create 2 NUMA nodes, but the OS will not know there's 2 NUMA nodes. So vSphere will treat it as 2 NUMA nodes. OS doesn't know. And the last one, the NUMA node is smaller and is not evenly divisible. Basically what happens is VNUMA gets turned off. So I had a 16-core machine and I go down to a 10-core machine. It's going to have a 16-core virtual machine with the underlying host now being a 10-core host. What happens is VNUMA basically gets turned off and stops working properly until you do a full power cycle. So to force update and review of NUMA topology, there are 2 settings. You have to go in the advanced section of the VM, which is, again, the NUMA auto size is true and the NUMA auto size once is false. These are turned off by default because there are a few Linux applications they have found that can cause problems when the NUMA node gets recalculated. So to be the conservative setting, VMware has went with the let's not recalculate on every reboot. Prefer HT. Prefer HT is off by default. It is a host setting and a VM setting, so you can set it either way. I recommend setting it at the VM level if you need to use it in all cases, in nearly all cases, but typically speaking, you only want to use Prefer HT in an edge case. And you only turn it on when you have more cores than the NUMA node size, but your memory will still fit into the NUMA node. Meaning, so if I've got an 8-core socket inside of our host, that each one has 8 cores, and I've got a 16-core or 16 vCPU virtual machine. If I have hyperthreading turned on, I can force it to fit into one NUMA node, because with hyperthreading turned on, I have 16 logical processors on the physical host. In most cases, you don't want to do this because your hyperthreading will only give you between a 20 and 30% performance boost, not the 100%. So if I'm running a high CPU workload in there, I will actually take a performance hit. Having my local memory, though, does help. So instead of splitting my memory in 2. So unfortunately, your mileage may vary, and the only way to verify for sure is to test and to test. And you need to test both methods. In most cases, actually, you want to have the extra CPU cycle. That benefit is greater than the NUMA penalty. NUMA host settings. So in most cases, I tell people don't touch most of these. This mostly covers how VMware determined when things move back and forth, and apparently we've got a small slide issue because the image is covered over part of the text. Sorry about that. What happens is every time a virtual machine is powered on, at first power on, it is determined what NUMA node to be attached to it. Even if it's a 2 vCPU machine, is attached to on the physical host to a NUMA node. If a lot of virtual machines that happen to be on one NUMA node all of a sudden all get hot or heavy use at one time, the host itself will see a NUMA node imbalance where a lot of CPU cycles are running on NUMA node 0, but not many are running on NUMA node 1. VMware will then go ahead and move things from NUMA node 0 to NUMA node 1. Most large virtual machines are never impacted by this as they're already balancing across multiple NUMA nodes. When VMware decides the host level NUMA node imbalance is so great, when it decides to move one, it moves the CPU schedulers immediately. So in other words, if you have a 2 vCPU machine running and all of a sudden it sees that this NUMA node 0 is too busy, it moves over that virtual machine to the other NUMA node. When it does, those CPU schedules automatically run now on NUMA node 1. However, all the memory still sits on 0, so everything when that happens is going to be a NUMA node remote lookup, which is going to have the NUMA penalty. And this happens for quite a period of time. VMware by default does not want to move that memory until it has to, because it wants to see if it's a short burst of CPU usage and it can move that VM back, or does it actually need to move the memory over. So by default, it basically trickles the memory over and only typically does the memory lookup for a CPU cycle and pulls that memory in and keeps it local now. Over a period of time, it will decide, oh, it's not coming back, I'm going to go ahead and move the rest of the memory. And it does that by a throttling mechanism, and it wants to keep that throttle very, very low, because if you turned it too high, it would affect the bus speed of all the other virtual machines running on that host. And most of the settings in there control how fast this works, what threshold it is, how fast it calculates all this. And VMware's done a great job of figuring all this stuff out. And I recommend never touch one of these settings, especially for those thresholds, unless you're talking to a VMware engineer. BIOS. So NUMA can be turned off in the BIOS, and a lot of times I see a lot of places where it is turned off in the BIOS and it causes other problems. Oracle systems, actually, Oracle used to recommend turning NUMA off. So if a machine used to be an Oracle server, it may be turned off in the BIOS. All hardware manufacturers today have NUMA turned on by default, but every once in a while I still run into a server that has it off for some reason. So you want to ensure it's enabled. And the funny thing is, every hardware vendor seems to have a different name for it. Some call it NUMA, some call it node interleaving. In most cases, you want to make sure node interleaving off usually means NUMA is on. Node interleaving basically is I'm going to interleave or weave together basically my memory into one large configuration. Of course, check with your hardware vendor. I don't know all the systems, and your mileage may vary. Rob, you want to walk through your fun testing scenario?
Yeah, sure. I mean, because I don't know SQL as in depth as Shawn, and I was really looking forward to the next time we'd meet up to discuss some of my latest findings. And so, I started doing NUMA testing, and so this was kind of a good chance to stop and step back a little bit. And so, before you go and blame NUMA, make sure your database is optimized. Database optimization will give you far more return on effort than tweaking some of these NUMA settings in most cases. Now, in this case, the app that we're using is HammerDB. I've configured it for 2,000 warehouses, which gives us a database size of 200 gigs. My kind of, after all the tests and all the config, my baseline for what looks good is 1.25 million transactions per minute. And then after testing for a while, all of a sudden it starts to crawl, and it comes way down to under 1,000 transactions per minute. I even saw it in the hundreds, which is like orders of magnitudes slower than 1.25 million TPM. So I tried a lot of things, and a lot of things that people would try are, well, let's, reboot this, reboot that. So we started tweaking with a lot of things, and I had some good known state, known bad state, and I could then see if I could fix it through NUMA settings. And in this case, our database started at 200, and then with all my HammerDB stuff, it grew to about 245 gigs. And then we had the really poor performance. So I said, Shawn, what can we do here? What can I help? It's like, hey, I've got this script. And so he gave me a script that was to optimize the database. We ran that script, and the script took about 50 minutes to run. And so looking at the array on the VM store side, I could see a ton of I/O happening. Okay, great, this is cool. And then when it was finished, my database was now 375 gigs, and I was like, wow, this is huge. You just inflated my database. What's going on? However, inflated or not, when I reran the test, boom, I was right back up at the results I expected, without having to do reboots and whatnot. And so then I played around with this, and then, well, let's shrink this database. I want to get my space back. Well, that pretty much undid a lot of what Shawn did. So reran it again, reran it with NUMA, saw the worst penalties while I was doing this optimization under heavy load. So I can't stress enough that this optimization has to be done in a maintenance cycle. The VM can still be up and operational, but it should be very low utilization. At this point, definitely not under the stress of full 10 clients of 160 users pounding it with Hammer, and brought it back to this. And so this was a great way to reset it. Now, amazing is that same script, after it was optimized, subsequent optimizations took typically 30 to 40 seconds. So running that script, like say on a weekly basis to redo the indexes and all that kind of stuff, gives you a ton of mileage. So if you've got database issues and you don't have a strong DBA on board, a company such as House of Brick that Shawn works for, or another, is a great investment to have them, an expert come in and look at the settings on your SQL Server. I just wanted to show some pretty screenshots. This is from the Tintri UI. Some of the HammerDB testing we did was, there's this way that you can, and I'll cover it in another slide, but we can step up our users and run a test and then step it up. So in this case, I've got 8 users, 16, then 32, then 64, 128. and I'm trying to find that sweet spot of where I could max out and get the most TPM, but without having the processors trip all over and create artificial CPU contention. And on the Tintri UI, one of the things that we can see is that as I start to add more and more threads in a guest than vCPUs are actually available, we start to see this host latency on that particular VM start to creep up as it starts to trip all over itself. Now, if we look over here, this is just our testing methodology. As I would change things around, I could control that we had a certain amount of transactions per minute. There it is, getting my performance penalty. I can change it back and bring it back up. And so this, we did a lot of control tests. All these screenshots came from Snagit video that I was capturing. So I've got tens of hours of videos capturing all of our tests so that we knew that we could reproduce the results and that what we were finding was very accurate. More screenshots here. Often in the background, we would have the ESX top window going on. We could see where if we were local or not. You know, and this was this one in particular started to show the build scenario, and I think it's the next screenshot that is a little more. No, never mind. There was a screenshot that may not have made the cut, but it was how we were stepping up our build sequence. In this one, this is where I was using CPU affinity to intentionally use a bank of CPUs from another NUMA node that were not from the same home node as where the memory was located. So this is where I would specify, you know, the third set. So this was when there's 32 available. This is where we want the last set of 8 for this 8 vCPU box. And here is just the same thing, pinning memory. So what if we move the memory and don't move the cores? What does that look like? And I would see the memory start to trickle over. And again, validated that all the findings from the VMware docs are in fact accurate. We did see it. The remote penalty was not too bad if there was no contention on the remote processor. But if we had loads on the remote processor, that's where we saw the biggest hits from these remote lookups. This is that screenshot that I wanted to show, that I thought was maybe a few back. This was doing the autopilot in HammerDB to do some stepping. So we had the test run in an autopilot where we would run the test for a 1-minute warm-up, run the test for 3 minutes, and then there would be a cool off there. So this is 5-minute test is the way this is configured. And then this was the number of vCPUs. So as this thing went out, the most that we could squeeze out with all of our client and host and CPU, everything taken into account, rerunning again and again. This was how we found how many users to hit it with to optimize to get the highest TPM before we started to get penalized by oversubscribing the CPU. And this is doing the same stepping, and you can see the CPU rises on the databases, the database server as we hit it. This one's actually the HammerDB client we're looking at, and we can see that we're trying to get it as close to 100% CPU. If you have things like ready time or if there's wait, that does not count towards CPU usage. So if you do not see CPU as 100%, there may be things that you can do to tweak it to first get it to 100%, and then it starts to get worse and kind of drop off a little bit from there. And so closing comments. Shawn, you want to just wrap us up here?
Sure. So basically, when in doubt, don't touch it. VMware does an amazing job of balancing it in most cases. The only times you really want to change it is if you A, know there's something going on that you want to go fix, or B, is if you happen to have a 6-core machine and then you want to move the setting down lower. But most of the rest of the settings, let it take care of itself. It does a great job. You know, this also really only fits the VMs that are larger than a single NUMA node. So to get the best performance, you want to make sure that if your machines actually will fit into a single NUMA node, and then you're running a 16-core hosts, you don't worry about NUMA until you get to 17 cores or vCPUs. So again, at the end of the day, just let VMware manage most of it. And if you have a question, post on a blog post, and someone will, or post it on a board, and someone will answer you for you, or come back to this and reread the deck.
And So here, I just want to thank everybody for attending. Shawn and I had a great time doing this. Feel free to reach out to us if need be on Twitter or otherwise. And there were a number of questions around getting the deck. We will put this together into a PDF, and I believe that Chelsea with VMUG is going to send that out, and we'll pass it back to Chelsea. And I just want to say thank you again on behalf of Tintri and House of Brick, and from VMUG, thanks for having us on today.
Sure, and I would like to thank Rob and Shawn for taking the time to speak to us today, and I'd like to thank all of you once again for joining us. Just as a reminder, you will receive a follow-up email directing you to the materials from today's webcast, and please make sure to complete that short online evaluation that will be popping up when you leave, and just let us know how today's session went. Thank you all for joining.